Okay, good morning class. So today we're looking at the last lesson on measurement, hopefully. Before we go into the revision exercise, the revision exercise is due for tomorrow. It's a fairly short exercise. Wrapping up measurement, okay? Emily, what's the problem? Why are you making sure you're scared? You didn't know you're making a skate, okay? So that one is done. I can take that one out. Alright, so your homework was exercise 8.2. I mean so. And this was on page 269. Alright, so we are told use the model of the rondavel in the example. What is the scale factor of the first model rondavel if the actual height of the real rondavel is 2.5 meters? So if you're looking at this rondavel, what is the height on this piece? 9. Not so? There's actually, wait, let me see here. This is the model, no? And the actual. So the scale factor, firstly I must convert this to the same SI unit. As you can see, this is in the model is in centimeters, and the actual rondavel or the actual structure is in meters. So that's step number 1. So the actual, so the height of the model was 9 centimeters. Is that correct? It's almost 6 and 3 gives you 9 centimeters. Is to the reality or the real piece, which is 2.5 meters. So you either convert both to centimeters or both to meters. Okay, I wasn't going to convert to meters, but otherwise I'm going to work with decimals, so let's convert everything to centimeters. Is 100 centimeters equals 1 meter. Right. So there's 9 centimeters is to, you multiply this by 100, I get 250 centimeters. Can you see that? So what is the scale factor? The scale factor is 1 is to 250 over 9. Okay. So the different question in the textbook. Okay, what's the question there? So it's not number 1. But you guys understand this now. They ask you for the scale factor. Okay? Or you can convert that. You can convert that as well to 1 is to what you know is 250 divided by 9 gives you 27,8 times bigger. Can you see that? So that's going by a scale factor of 27,8 times larger. Okay. Yes? Sorry? What's the answer there? 0, 003. There we go. Lovely. So they just went from reality to the model. So what they did was, they said divide both sides by 250 instead. So that's going to give you 9 over 250, which is 1. What is to 1? Did you see that? And this is what you're looking at, which is 0.03. 6 is to 1. You understand? Okay. Yes? 0.00. They divided this by 1,000. Remember, this is in centimeters. Not so. So I think they went with 9 over 2,500. That's the answer they have. But how many centimeters are there in a meter? 100. So they made a mistake and they wrote 1,000. Understand? Where am I wrong? So they are wrong. Anything else? It's a bit frustrating if you're doing the sums and you're not getting the answer that they have and can't find where you're going wrong. But at times they are also, not often, but there is times where they are wrong, like in that case. Okay. Okay, so in number 2, any issues here? Do you have a problem in number 2? Yes? A farmer builds a cylindrical water tank to store water. Each one holds 3 kiloliters. So it's a cylindrical tank, so it's in the shape of a cylinder. Okay? The volume, it keeps a volume of 3 kiloliters. So 3 kiloliters is the same as 3,000 liters, which is the same as 3 million milliliters. But now 1 milliliter is equal to 1 centimeter cubed. And that is the reason why I converted that capacity to milliliters. Okay? So when we're working out the volume of a shape, we work it in centimeters, meters, and so on. Not so. That is why I converted that to milliliters. So that's the same as centimeters cubed. The farmer wants to build a water tank that holds 15 kiloliters. If he wants to keep the dimensions of the tank in proportion, what scale factor should he use for these dimensions? Okay, so basically, I didn't even have to go through all of this. So they only wanted the scale factor. So all of this, in this case, is not needed. So, in other words, remember the volume, the new volume is equal to K cubed times the original volume. Okay, you can use that formula there. If it was area, I would have said K squared. So the new tank must hold 15 kiloliters. So that's going to be K cubed. I'm going to solve for K, so they want you to work out the scale factor. And the original volume is 3. So what do I do is I divide both sides by 3. I then get 5. So K is then going to be the square root of 5. So it must go a cube root of 5. So it must go through an enlargement factor of the cube root of 5. What's the answer they have? Cube root of 5. So you go the cube root of 5 is 1.71. Okay, as I said, you don't need this. Okay. Any problem number 3? Oh, you're going to have a problem now with everything. Yes, okay. I actually wanted to start past papers today, but okay. You girls are that kind of type of girls. You have a problem with everything? No? It's a joke, no? Alright. An advertiser wants to add a giant plastic capsule to a billboard advertising a new vitamin pill. Okay? Remember, we had the capsule calculation before, not so? Using the information about the there we go in exercise 8.3. Give the new dimension of the capsule is a scale up by 100 times. So if you're looking at 8.3, I hope I didn't delete it, because I know I deleted a page here. There we go. Yeah, that is the capsule that they're referring to. Okay, so let's just cut that out. Okay, so that's the capsule that they are referring to in exercise 8.3. Using this information, but give the new dimensions of the capsule. Okay, now the dimensions, if this is going to go 100 times bigger, then that is going to give you 75 centimeters, not so? So that is going to be 0.75 times 100. Then you multiply this by 100, I'm going to get 150. Not so? Then it says calculate the scale factor that the new surface area and the volume if the giant capsule should have the length of 3 meters. But remember, this was from this midpoint, no? That was this 150. Not so? If I'm not mistaken. No? Okay. So you must calculate the scale factor. And the new surface. Okay, so the scale factor for the surface area is going to be k squared. And what is k in this case? It's going to be 100 times. So for area is going to be 100 squared, which is 10,000 times bigger. Okay, in terms of the surface area. So just going back to the previous question, what was the surface area? The surface area of the new piece times k squared times the surface area of the original piece. What was the surface area that we calculated in 8.3? Just go back.
5,
Sorry? 5 comma 3 what? 0. So it's times k squared, which is 100 squared. So that should give you 100 squared times 5 comma 3. That's going to give you 53,000. Now, we don't have the rest of the digits there, but if we did, it would have given you a more accurate solution there. So here we're looking at 53,000 units. In this case, it's going to be centimeters squared. Otherwise, you could have converted to meters, you get a smaller answer there. Well, the volume is going to be the volume for the k cubed is going to be 100 cubed, which is 1, 2, 3, 4, 5, 6. So a million times bigger for the volume. So the volume of the new piece is going to be k cubed times the volume of the original piece. So it's going to be 100 cubed times what did the volume in 8.3 work out to be? 0.88. So it's going to give you 880,000 centimeters cubed. Okay? And that's how you work it out. You don't have to, once you've got the volume already calculated and the surface area already calculated, you don't have to recalculate the surface area and the volume with the new dimensions. Why? Because why? We can just enlarge it by its k factor. Volume is going to be k cubed, and for the surface area is going to be k squared. Okay. That is all they want you to familiarize yourself with in this what's his name here. Alright. I'm sure you guys had no problem with number 4. Okay. So that now brings us to the revision exercise. Okay? Revision exercise. It should be fairly simple. It's a 3D object. For A, it's actually a. What is this?
Sphere.
A sphere. It's not a circle. Is a circle 3D? Come on now. What's wrong with you guys? There's a cone. We have done something like that. Not so? Right? C. What is this? A cylindrical shape where you got a cut out of it, no? Right.
What do you call it? Prism? Yeah, it's a prism.
A what?
Triangle prism.
The angular prism.
The curved shape.
This is a right prism.
Oh, it's not right.
Okay.
No, the
So-
triangle. The cutout piece.
Oh, this piece.
Yes, this one.
Yeah, curve, yes.
Oh.
Alright. If it's a cylinder with a cut out piece then, eh? Yeah, relax. Okay. It's okay. It's okay.
No, it's not.
It is okay. Okay, relax. Relax your body. And here we got a conical shape or a cone that is also cut out. Yes. Sorry? C yes? No, the height. Well, the depth of this cone. The radius is 5. No. The circumference is not 25. It's from here till there is 25. Okay. Well, that's how I see it. Now I'm feeling better since you're agreeing with me. Okay, that's number 2, a cone again. Number 3, you got the sphere. And that's it. Sounds like somebody's done it already. Alright, so that is the work for tomorrow's lesson. Okay. So also I'm going to start past papers, so I'm going to stop the video at this point. You're going to know. Which section do we still need to do? Is this the last?
Yes.
Yeah. And we're going to stop the video at this point and we're going to choose a paper and which we're going to work from. Okay.